Hi everyone, today we're going to be working with complex rational expressions. These are expressions that are fractions within fractions, and it combines all of the skills of what we've been working with so far with simplifying and dividing and multiplying rational expressions. So let's just go ahead and start. You can see here that I have 4/9 over 9/5 minus 10/9. What I want to do is identify the fraction bar that sort of separates one rational expression from the other. This fraction bar here is really a division symbol, so I'm going to rewrite this as a division problem. So this is really 4/9 divided by the quantity 9/5 minus 10/9. Now that I see what I have here, I need to first start with, using the order of operations of course, I need to start with subtraction inside the parentheses. And the only way I can take care of this subtraction is to find a common denominator. So the common denominator, I'm going to leave this first part the way it is, common denominator is going to have to be 45, which means that I need to multiply the first fraction by 9 over 9. So I'm going to get 81 over 45. Minus, I have to multiply this times 5 over 5, so that's going to be 50 over 45. And now I'm ready to actually subtract in the numerator. So I have 4/9 divided by 81 minus 50. So 81 minus 50 is going to give me 31 over 45. Now it's become just a simple division problem. I know that when I'm dividing with fractions, I need to rewrite the problem so that it is multiplication of the reciprocal. So this is really 4/9 times 45 over 31. Now I look for common denominators within the numerator and the denominator. I said common denominators. I meant to say common factors within the numerator and the denominator. This is 4 times 45. Notice I am not multiplying, and 9 times 31. I notice that in 45 and 9, of course, I have a common factor of 9. So I'm going to rewrite that so that I've got the 45 is going to be rewritten. So it's 4 times 5 times 9. And then the 9 times 31 is going to stay as is. I've identified my common factor that can be canceled. And now I can rewrite my numerator. So that's really 20 over 31. And that's my simplified answer. So to summarize, keep in mind that when you have a complex fraction, you're always going to be looking for that fraction bar that is really the division symbol that separates the expressions. So when you rewrite this as a division problem, it becomes clear using the order of operations where you need to go next. This one did not have any variables in it, so we did not have to worry about exclusions. Let's take a look at question 2. So again, looking for the fraction bar that divides the rational expressions. In this case, this is the fraction bar that is our division symbol. So this problem is really the quantity 1/5 plus 5 over 4 divided by the quantity 5/3 minus 2 over 15. And I do put parentheses around these, and that's just to remind myself that this entire numerator is a group by itself, and this entire denominator is a group by itself, so that I have to take care of the arithmetic in those parentheses before I can do anything else. All right, again, I need a common denominator. In this case, for the first rational expression there, it's going to be 20. So when I rewrite this, this is going to have to be multiplied by 4 over 4. So I'm going to get 4 over 20. And then this one's going to have to be multiplied by 5 over 5, so that's going to be 25 over 20. For the second rational expression, it looks like it's going to be 15. So the first fraction needs to be multiplied by 5 over 5, so I'm going to get 25 over 15. Minus, and again, this has already got a denominator of 15, so I don't have to multiply by anything there. I'm going to do the addition in the first set, so that becomes 29 over 20. Divided by, and the second set, take care of the subtraction, 23 over 15. It's division of a fraction, which means that I have to multiply by the reciprocal, so I'm going to write 29 over 20 times 15 over 23. So what I have here is 29 times 15 over 20 times 23. And I was supposed to write a 23 here. Sorry about that confusion. Looking for a common factor. Looks to me like it's going to be 5. So if I cancel out, I'm going to just go ahead and directly cancel out the 5. If I divide a 5 from the 15, I'll have a 3. And if I divide a 5 from the 20, I'll have a 4. So 29 times 3 is going to be 87. And 23 times 4 is going to be 112. And that's my simplified answer. Hi guys, I wanted to go over a problem that has variables in it to get us used to seeing these the way you'll really be working with them. So we have x squared over 4 over 2 over x squared. You can see here that the fraction bar in this position is what is separating the two rational expressions. So that's my division symbol. So I've got x squared over 4 divided by 2 over x squared. This is division of two fractions, and keep in mind there is nothing within each of these that I need to simplify at this point. So I'm going to just rewrite these as multiplication of the reciprocal. So I've got x squared over 4 times x squared over 2. As I set this up, I've got x squared times x squared over 4 times 2. There is really nothing in common that will get canceled out. So the answer in this case is going to be x to the 4th over 8. Pretty simple. Nothing to have canceled. The thing we want to address, though, are the excluded values. So let's take a look at that here. What we want to do is take a look at where we have variables in the denominator. So in the original expression, when we see that we've got it written out as division, I have x squared in this denominator, which means that I have to say that x squared cannot equal 0, which means that x cannot equal 0. And then when I rewrite it, there is no variable in the denominator, so the only one I have to worry about is the variable in the original division problem. If there were another variable in the denominator, once I rewrite it as multiplication of the reciprocal, then I'd have to deal with that variable as well. But in this case, it's just the one, so that's it. We have our excluded value, and we also have our simplified rational expression. So let's take a look at one more. We've got here another rational expression with rational expressions in it. It looks to me like we are seeing that this is our fraction bar that's dividing the rational expression. So we have 25 divided by the quantity 5 over x plus x squared over 25. I need a common denominator here in order to add before I can do anything else. That's what the order of operations would require me to do, is to add here first. So this is still 25 divided by something. Looks to me like our common denominator is going to have to be 25x. So that means the first fraction needs to be multiplied by 25 over 25. When I do that, I get 125 over 25x. And then the second one is going to have to be multiplied by x over x. So when I do that, I'll get x cubed over 25x. Now we're ready to multiply, or excuse me, add in the numerator. So we have 25 divided by, I'm going to write this as x cubed plus 125 over 25x. So now we have this division problem. We're dividing by a fraction, so that means we need to multiply by its reciprocal. So this is really 25 times 25x over x cubed plus 125. Now keep in mind that anytime you have an integer, it does have a denominator of 1. So I'm going to make it look like a fraction because it is, technically. And I'm going to look to see if there's anything that can be cross-canceled. Even if I factored here, which by the way, this is a sum of cubes, even if I factor, it doesn't look like we have anything that we can, sorry, that's supposed to be minus 5x. There is nothing that will cross-cancel. So I'm going to go ahead and just multiply the numerators. So 25 times 25 is 625 times x. And you can either write this denominator in factored form or in its original multiplied form. I'm going to go ahead and write it in its factored form. It's okay to leave it that way. And we are finished with this part of the problem. There's my simplified rational expression. Thing I want to do now is make sure that I have my excluded values taken care of. So let's take a look. Up here, we can see that we have in our original division problem, x is in the denominator, so for our excluded values, we know that x cannot equal 0. And then I'm going to check to see what happens when we get to our division problem. We have another factor or another expression with a variable in it, and we will need to factor that out, which means that these are the two factors that cannot equal 0. So that means that I've got x plus 5 can't equal 0. So in this case, that means that x cannot equal -5. And then when I set this next one not equal to 0, this next factor not equal to 0, I would get an imaginary solution when I use the quadratic formula. So because that's imaginary, I'm not going to need to worry about it. But always check. If it's another quadratic, in this case I know this is going to turn out to be an imaginary, but always check to see if it's going to be imaginary before you state or not state its exclusions. Okay, so we're going to give this one more try. This one is a little more fun than the last. So we're going to take a look to see where our fraction bar is. That's our division symbol. And so we have here u squared over 3 minus 1 over 3 divided by 4 over u minus u squared over 12. So within each set of parentheses, I need to take care of the subtraction. I already have a common denominator here, so that's really great. I'm going to just rewrite that as u squared minus 1 over 3. And the common denominator here is going to have to be 12u. So I need to multiply the first fraction by 12 over 12. That'll give me 48 over 12u. Minus, and the second one will have to be multiplied by u. And so I'll get u cubed over 12u. That gives me u squared minus 1 over 3 divided by 48 minus u cubed over 12u. So let's take a look at the next step. We're going to multiply by the reciprocal. So I have u squared minus 1 over 3 times 12u over 48 minus u cubed. This is not a difference of cubes, so I really can't factor it. The only thing I can do here is check to see if there's anything that can be canceled out otherwise. This could be factored. But because it won't cross-cancel with anything, I'm going to leave it alone. 3 and 12 definitely can cross-cancel. Divide both of those by 3, you get a 1 here and a 4 there. Nothing else can be factored. This can't be factored anymore. So I have 4 times the quantity, u squared minus 1, and in the denominator, it's just going to be 48 minus u cubed. And because this isn't factorable, there's nothing more that can be done. That's actually my simplified rational expression. So I want to take care of those excluded values. I'm going to go back up here, and I'm going to check for variables in the denominator. I can see that in my first division statement that I have u in the denominator, so for my excluded values, I know u cannot equal 0. And when I get to this statement down here, after I have rewritten it as multiplication of the reciprocal, I would have to state that 48 minus u cubed cannot equal 0, and then solve accordingly. So if I subtract 48 from both sides, I get a negative u cubed, cannot equal negative 48, and I'm going to